This is sadly the last video for the unit circle. This is going to be how we write it in terms of radians. We talked in the last video how to figure out the points. We could figure out the points on this thing. It's expected to be able to find the points. We are just concerned about how to figure out the angles in terms of radians here. So we know that if we look at our circle here, here, and here, this is 0 degrees as our starting point. This is also 0 radians as our starting point. So we're starting there. And a radian is said to be a dimensionless unit. So we could write 0 radians or 0 rad, but it's dimensionless because it's the number 1. So it's really just 0 right there. So it starts off at 0. Now, if you think about this in terms of degrees, we were here, so this was 30, this was 45, this was 60. I'm gonna kind of blend these two ideas together. This was 0 radians. The whole circle's 2 pi. This must be pi radians. If we consider the upper half of the circle, this is pi. I cut it in half. This is pi over 2. Because pi divided by 2. I cut this in half again. This is going to be pi over 4. So I'm just cutting that in half every time. So I'm going pi, pi over 2, pi over 4. So we know that's pi over 4. This is pi over 2. That's 90. That's pi over 4. And we should know that this is 3 pi over 2. That should be pretty automatic right there. That's 3 pi over 2. That's 270 degrees. You should know what that value is. That value is 3 pi over 2. I would encourage you to, memorize that value. This value right here is 2 pi. You spun around the whole thing. 30 degrees is equal to pi over 6. Reason being, 180 divided by 6 is 30. 180 divided by 6 is 30. That's the shortcut to looking at that. Now, if you think of this as pi over 6, this is 30 degrees. 30 plus another 30 is going to give me 60. The way I can represent that in terms of radians is by realizing that this value right here is equal to 30 degrees plus 30 degrees. So it's pi over 6 plus pi over 6. In other words, it's equal to 2 pi over 6. In other words, it's just you divide that by 2, you divide that by 2, divide the numerator by 2 is pi, because 2 pi divided by 2 is pi. 6 divided by 2 is 3. You can reduce it. So it's pi over 3 right there. So let's just erase this thing right here. Let's realize this is pi over 3. This is pi over 4. That's pi over 6. Wait, what's this again? This is pi over 6. This is pi over 4. This is pi over 3. Very important values here, here, and here. Now, if you think of these values, and you want to reduce all your fractions always on this thing. The way I do it, the quickest way that I think of to deal with fractions is deal with this number as much as I can. I stress that number. I think of that number as a way to convert to fractions quickly because what you can do is you can make that the same number, find a common denominator quickly. You want a 6, that 6 has to go up top. So I try and use that value as much as I can. So if we see here to here is pi, we subtract a little 30 degrees. So this is 30 degrees we subtract off from the pi. In other words, it's pi minus pi over 6. In other words, you have a 6 down there, you must have one up top. So this value right here is really 6 pi minus pi is 5 pi. Denominator is the same, so it must be 6. Because you see the 6 It's right there. So this value right here is 5 pi over 6. I suggest you erase this, your scratch work. Your scratch work is your scratch work with this. It becomes cluttered if you leave it. Your goal is to get it into this form. So this is 5 pi over 6. Now, 45 degrees is the same thing as saying pi over 4. So I'm going pi minus pi over 4. So this value would be pi minus pi over 4. In other words, you see a 4 and a 4 here. So it's going to be 3 pi over 4 because you see the 4's are right there. So it's going to be 3 pi over 4 right here. So this value right here is 3 pi over 4. And there's another trick that a lot of people show this way too. This is pi over 4 plus another 45 degrees is 2 pi over 4. So that's our pi over 2. Since this is pi over 4, 2 pi, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. You can do that way too. It's a kind of a neat trick. You can do it that way. But I just think it's pi minus pi over 4. This value right here is pi minus, it's the large angle because we're going back the furthest. The large angle is pi over 6 or pi over 3? Pi over 6. Pi over 6 is the little one, so it's minus pi over 3. Now you see there has to be a 3 here, there has to be a 3 below. In other words, that value right here, 3 over 3 pi minus pi is 2 pi over 3. So this is 2 pi over 3 right here. Two pi over 3. All right, so now we're here. I'm wanting to use this value again. So this is pi plus another 30 degrees. So this is pi plus pi over 6. So that value is 7 pi over 6 because you see the 6 shows up right there. So this is 7 pi over 6 for this value right here. Let's see if we can do our kind of trick thing too. So 3 pi over 4, 4 pi over 4, 5 pi over 4. So this should be 5 pi over 4. But in other words, this is pi plus a pi over 4. Pi, 4 pi over 4 plus pi over 4 is 5 pi over 4. So this is 5 pi over 4. Here. This right here. We're going pi plus another 60 degrees, so pi plus pi over 3, because that's the big one. In other words, that's 4 pi over, so it's pi plus pi over 3. You have to find the common denominator. So it's right there. So this is 3 pi plus pi is 4 pi over 3. So this is 4 pi over 3. Now I want to show you how you can deal with this. Like you can figure out these values, and then I'm going to show you a little shortcut. We know that this whole length of this arc length of this circle is 2 pi. We can go and say 2 pi minus the little angle, so 2 pi minus pi over 6 must be this angle. I'm going to show you how to deal with it because it's important to be able to deal with this. There is a 6 down here. We have to find a common denominator. There has to be a 6 down there. So this value up top, we also have to multiply by a 6. Because 1 will be right here, and we know 1 times 2 pi is just 2 pi, so it doesn't affect anything. So the numerator really is 6 times 2, so it's 12 pi over 6 minus pi over 6. So 12 pi minus pi is 11 pi over 6. So this value right here is 11 pi over 6. And another thing you can note is that 11 pi over 6 plus a pi over 6, another 30 degrees, that's 12 pi over 6. 12 over 6 is 2, so that's 2 pi right there. So if you're going to add another pi over 6, that would give you 2 pi, and that's a way to kind of check. The way that I do it, and this is just how I kind of think of this, is that I like dealing with this value as much as I can. So I try and deal with understanding that this is 5 pi over 6 plus another pi going around, plus another 6 pi over 6. That is going to give me 11 pi over 6. So I look at these values to deduce what those are. So right here, you're at 3 pi over 4 plus another pi around. So that would be 7 pi over 4, because 3 pi over 4 plus another pi, in other words, it's 4 pi over 4, would give you 7 pi over 4. So that value is 7 pi over 4. Let's erase this. Lastly, if you're wanting to get this one, you look at that. You see there's a 3 in the denominator. You have to add, so it's 5 pi. So it's right here, it's going to be 2 pi over 3 plus 3 pi over 3. In other words, the pi going around. So I'm going 2 pi over 3 plus pi. There has to be a 3 in the numerator and denominator there. In other words, that is equal to 5 pi over 3. So right here, that value, because you're going 2 plus 3 is 5. So this is 5 pi over 3. What is important, though, is not to think about this as a race, as a speed thing. You want to just be relaxed, and you want to just understand that worst case scenario, you just deal with fractions. You think of everything in terms of pi over 6, pi over 4, pi over 3. If you forget those, you can derive those, and you just keep going with the whole circle, and then you get this thing right here. We can just figure out some points. I'm not going to figure out all these again in the last video I did. This is going to be the longest side because this is the longest x value. So it's square root 3 over 2. It's going to be a half. These are the same. So it's square root 2 over 2, square root 2 over 2 up top. This can't be repeated, so this must be 1/2 square root 3 over 2. They flip right there. And then you just keep going around this way. And remember that the cosine terms along anything to the left of that must be negative. For the sine terms, those are our y coordinates. Those values, this is the negative portion right here. So you just keep repeating this process, and you kind of look at what y values are the same. You look at the x values, and then you go from there. Okay, so kind of cool.